Welcome to the Code of Life. I'm Randy Neal. Okay, quick pop quiz before we start, and you probably know the answer to this already. What is the deadliest predator on Earth? It's not a shark. It's not a bear. It's a mosquito. What's that saying? If you don't think mosquitoes are annoying, try going to bed with one. Mosquitoes carry disease, and when they bite you, they can pass that disease on to you. The most deadly they carry is malaria. Malaria kills an estimated 400,000 people every single year, most of them children, and in many countries, it's the leading cause of death in children and pregnant women. But malaria is not just a health issue, it's also an economic issue. Malaria-free countries, for example, have 5 times greater economic growth than countries that suffer from malaria. Genomics is the key to eradicating malaria in many parts around the world, and 2 scientists are at the forefront of that fight, and we're speaking with both of them today. Dr. Lee To is a social scientist at the Institut de Recherche de la Santé IRSS in Burkina Faso. And Dr. Jen Gardy is a Canadian scientist with the Bill and Melinda Gates Foundation's Malaria team. She is the Deputy Director, Surveillance, Data, and Epidemiology. The foundation has vowed to eradicate malaria by the year 2040, which is amazing, and we're going to talk more about that. And she is in Chicago today. Welcome to both of you.
Thank you, Randy. It's a pleasure to be here.
Dr. Leoto, let's start with you. Can you tell us how dangerous malaria is in Burkina Faso?
Malaria is a big health issue here in Burkina Faso. For instance, in 2008, we registered 11 million of malaria cases and 4,294 deaths, in which 3,180 children under 5. You can see how is the burden of the malaria here in the Burkina Faso.
Dr. Gardy, I guess that kind of answers the questions that I was going to ask you. Why has the Bill and Melinda Gates Foundation vowed to eradicate malaria by 2040? But clearly that's the answer.
Yeah, it's a huge burden. The world's most vulnerable countries. And the thing is, it's a preventable burden. We know how to fight malaria. We've successfully eliminated malaria in hundreds of countries around the world, including North America. A lot of people don't appreciate that malaria was actually a big problem throughout the United States and even some of the southern parts of Canada well into the early 20th century. So this is something that we can stop. We have the tools, whether those are drugs, whether those are mosquito control tools, but it's just a matter of getting those tools to the right places, the places where this disease is for various reasons hanging on. Yeah, we think eradication is possible within our lifetime.
So both of you then, what are the tools that we have in the toolbox? Jen, I'll start with you again. What did we use to eradicate malaria in North America? And why don't you think that'll work in other parts of the world? And what are we doing right now to help eradicate it?
Yeah, so fantastic questions. It's a really interesting question, too. There's a lot of parts to the answer because malaria is a pretty complex disease. You've got a parasite and you've got a mosquito vector that carries that parasite around. And you really need both parts of the equation for malaria to thrive and keep transmitting. But that also means that if you knock out either one of those pieces, you can stop malaria. So it turns out that the easiest interventions to really deploy at a big scale, like eradicating malaria worldwide, is vector control interventions, things like bed nets. Sleeping under a bed net can prevent you from being bitten by the Anopheles mosquitoes that carry malaria, but you need other approaches too. Not every Anopheles mosquito likes to be inside. Some of them like to be outside. Not everyone will bite at night. Some of them like to bite in the daytime. So you need other vector control interventions. And what we saw in the 20th century was that things like insecticide spraying was extremely successful. I mean, it's a bit of a carpet bombing approach, but it worked. It drove mosquito populations down significantly. And you get a lot of side benefits with that too. Other mosquito-borne diseases will also drop. So That's what you've got on the vector side at the moment. On the parasite side, we have a number of fantastic treatments that can not only be given after somebody's sick with malaria to cure them of the infection, but can also be given before they even get sick. It's a prophylactic treatment. So we can do things called mass drug administrations, where ahead of a malaria season, because malaria is very seasonal in most parts of the world, we can go out into the population, make sure everybody is given one of these prophylactic drugs, and that helps drive things down too. So these are sort of the mainstays of our current toolbox, but what's clear is that the tools we have now have gotten us a long way, but they won't get us all the way to the end of our eradication journey. We need to really kind of step up our efforts, and this is where Target Malaria's work and what Dr. was doing really comes into play. We need what we call transformative tools, things that when in that last mile of malaria eradication 10, 20 years from now are going to be those really innovative, creative things that kind of mop up that last little bit of malaria. And one of those is genetically modified mosquitoes. And that's a perfect topic for Dr. To talk about. She's the expert here.
And I want to ask you about that, Dr. Tobe. So how does what you do fit into that, and how do you use those transformative tools to talk to the community to hopefully help in the whole community helping to eradicate malaria?
When you work on the field, you work with the community. It's you need to explain what you are doing with the community to be sure that you can get their support for the research. And also, when you talk about the genetic modification, often they bring some a concern, some fear from the community perspective. And because that we think that tools is very important and can help to eliminate the malaria, we need to work closely with the community to make possible this research, and in the future to improve the acceptance of this technology. That's why for the target malaria in general and in the Burkina Faso year, the stakeholder engagement is one of key piece of this research. That means take time to communicate with the stakeholder, to collect their concern and provide the answer, to be sure that they understand well, they support this research, and at the end, they are happy to use the finding of this research.
Dr. Toe, what is some of the hesitation? Because I think it's probably the same question that people have around the world about anything that's genomically altered. They're scared of it because they don't understand it, and they think it could lead to something worse possibly. So when you talk to the community about genetically modified mosquitoes, what do you say to them to calm their fears and help make them understand?
The first thing is that to take time to explain the concept of the genomic. Take time to talk about the biology of the mosquitoes and the link between the mosquitoes and the malaria. And because of the malaria is the huge problem, they can understand that we need to do this research. And people can understand the science, but you just need time. You just need to use the good work to explain them. And when you find the best way to explain this science, what we notice in the field is that the people understand the add values of their science, and they can support the research. Sure, they can have some concern, but if you can bring the answer to this concern, they are okay. They can continue to support the research. And sometimes, you can understand some group who talk about who emphasize on the risk of this research. I want to say that for everything there is a risk. I can say if you want to do something, there are a risk, but you need to identify the potential risk to minimize the risk. To be able, you do the research, the responsible research, and to come with something that can help to push back the malaria, which is the big problem in Africa.
Dr. Gardy, thank you. Dr. Toe, just to expand, you have to kind of look at the risk and manage the risk. And I'm sure this is something that you, working at the Bill and Melinda Gates Foundation, have to explain to people all of the time. Can you expand a little bit more?
Yeah, I think with any new disruptive technology, and certainly genetics and genomics, I think falls under that bin, there's always going to be uncertainty, and that leads to concern. And uncertainty sort of seeds people's doubt and discontent around a particular issue. I think genetically modified foods, for example, really kind of showed what not to do when you're introducing a disruptive technology. And, as Dr. Toe said, it really is about engaging with the community and being very open and being very transparent and making sure they understand the science, but also as it pertains to their own life. Why does this matter? With GMO foods, for example, the debate was always in the scientific space. It was always very technically focused. And it seemed as if many of the scientists that were participating in those discussions fundamentally weren't listening to the community. They weren't acknowledging concerns that were coming from the community members. They were just relying on things like, this is safe, this is totally safe, we tested that, this is fine. And so there's sort of a disconnect there. And so that's why with the genetically modified mosquito portfolio, and it's a big portfolio, this includes everything from infertile mosquitoes that just can't propagate the next generation of bugs to much more sophisticated genetic constructs. So the technical details are really complex in this space. Just trying to go out and explain the hardcore detailed science. I mean, even I, as a professional genetics and genomics researchers, don't fully understand all of the many different constructs that we're using in this space. But skipping over the technical details to focus on the core science and the core community concerns are what you need to do. You can draw some risk comparisons or some scenario comparisons. You can say like, well, fundamentally, gene-drive mosquitoes or genetically modified mosquitoes are a way of bringing the mosquito population down in a way that doesn't rely on mass insecticide campaigns, but ultimately they're reaching the same goal. They're just eliminating mosquitoes from an area. So you can draw some comparisons, but really, as Dr. Toe said, the most successful strategy is listening to the community, relating this to their lived experience, and really connecting the dots between this technology is something that will bring the mosquito population down in your area, and that's going to bring malaria down. It's going to keep your children safe. It's going to keep your family safe. So it's all about listening, acknowledgement, and really confronting the lived experience of people as opposed to the technical details.
That's something, as I've been doing this podcast and interviewing people, we did one last week talking about vaccinations as well. And the science is amazing, but just, if not more important, is that community engagement, truly explaining what the benefits are of a scientific breakthrough to people like me who know nothing about the science. That's oftentimes, I imagine, even a kind of a tougher, tougher than coming up with the technology in the first place.
I think it is. Risk communication and science communication isn't something that we're regularly trained in. You might go through your entire PhD program and never get a formal lesson in how to talk about your science and how to share it in a way that works for your audience. I think a lot of scientists kind of rely on what in communication circles we call the knowledge deficit model of science communication, which is if you just give people information, technical information, they will somehow arrive at the right conclusion, and that doesn't work. I mean, there's an endless series of papers that show that this default mode for how we talk about our science, how we talk about our research, doesn't work. It's things like anecdotes, stories, connecting things to people's own experience. That's what makes a scientific message land. So whether the topic is vaccination, whether it's genetically modified mosquitoes or genetically modified foods, you can't start with the science, you can't start with the facts. You have to start with the people and their stories, their feelings, their emotions, and their perspectives.
And that's my question then to you, Dr. Toe. What would be your message to anybody listening to this? Thinking of a future where malaria doesn't kill any more children or pregnant women.
The malaria is a real problem here. And as a African and Burkinabe researcher, when you see every time children deaths because of malaria, and that is a treatable diseases, that is a problem. You can understand that for us, we need to do this research, be able to come with a tool which can be complementary to the existing tool. The problem is that when you do the research and you don't have the support, the community support, that could be difficult to end this research. That's why we think that we need to take time to talk with the community, to explain, because we know that they can understand. We choose to integrate in this target malaria project the stakeholder engagement approach to be sure that we have the support of the community to conduct the project at the end of the research to get the opportunity, to have the opportunity to make acceptable the funding of this research.
Dr. Gardy, why do you do this? What makes this so fulfilling for you?
I think at the end of the day, for me, it's all about seeing scientific technologies that I find personally really exciting, like genetics and genomics, being used as a public good, being used to make a real tangible difference in our world, especially, now that I'm working on malaria, which is obviously a big issue in sub-Saharan Africa, seeing genomic technology being used to improve the lives of some of our world's most vulnerable populations is incredibly rewarding. And what makes it even more rewarding is that it's African scientists that are doing and leading this work. Before I joined the Gates Foundation, I was in BC for many years working on using genomics as a tool to understand pathogen transmission. How do infectious diseases spread from person to person? how do outbreaks happen? How can we use that information to control and prevent future outbreaks? And it was really exciting. It was very cool to see, but it was very niche. It was a new field. It was only happening in a few select places, British Columbia, over in the UK, CDC in Atlanta. But now to see, just in a few short years, really over the last decade, to see this technology being used worldwide, including labs in Burkina Faso, labs in Ethiopia, labs in Ghana, labs in Mali, to see researchers there embracing the use of genomics as a tool to combat infectious disease and making the discoveries, making those insights that are then immediately feeding back into their own population to improve people's health. I think that's why I get up in the morning.
That's wonderful. I mean, both of you are responsible directly and indirectly for potentially saving millions of lives in the years to come. So thank you both for being so extraordinary and also for talking to us today.
Okay, thank you.